Good day, students. Welcome to mathgoodserve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 36 to 39 of the Algebra 2 Trig January 2016 New York Regents exam. All right, let's take a look at question 36. It says, find the exact roots of x squared plus 10x minus 8 equals 0 by completing the square. Okay, so we have x squared plus 10x minus 8 equals 0. Okay, so if we want to complete the square in this equation, first thing we're going to do is create an incomplete square, okay? An incomplete square is of the form x squared plus bx. And then we'll complete the square by adding b over 2 square in order to create a perfect square trinomial, okay? So let's create the incomplete square here first by moving this constant term to the right. We do not know if this term makes this a perfect square trinomial, so we just toss it over to the other side, okay? So we just add 8 to both sides, and we're left with x squared plus 10x equals 8. Now on the left side, we have the incomplete square that I was talking about earlier, x squared plus bx. Now what we're going to do is we're going to add a term to make this incomplete square a complete square, also known as a perfect square trinomial, okay? But since we're dealing with an equation, whatever we add to the left side, we have to add that exact value to the right side to preserve equality. Now, what do you add to an incomplete square of the form x squared plus bx to create a perfect square trinomial? You simply add b over 2 square, okay? So in this problem, b is the coefficient of x, which is 10. Divide that by 2, you get 5, and then you square it, you get 25. Okay, so if I add 25 here, guess what? I have created a perfect square trinomial on the left side of my equal sign. In order to preserve equality, I have to add the same number to the right side of my equation. Okay, now let's go ahead and factor this perfect square trinomial. Now, since it is a perfect square trinomial, it factors nicely into the form. You just root the first term and the last term. Notice they're squares, and then that basically becomes x. You bring down the middle sign, whatever the sign is after the square, x plus, in this case it's plus because you have a plus here, b over 2 square. That's the factored form. Okay, that's one way to factor it. You can use a shortcut, or you can use the X scheme or the box method, whatever makes you happy. I'm going to use the shortcut here with the first term and the last term of your perfect square trinomial. Bring down the middle sign. Okay, it's not always plus. Sometimes it could be minus. That leaves you with x plus 5 quantity square equals 8 plus 25 is 33. All right, now to finish this off, we're going to get x isolated. How do we isolate x? We take the square root to get rid of the square, and then we subtract 5 from both sides. All right, so let's do it. So you root both sides of the equation. Let me write it again so it doesn't look messy. So we have x plus 5 quantity square equals 33. So we're taking the square root of the left side and the right side. Now note, anytime you take the square root of a square, you have to introduce plus or minus, or your absolute value quantity. So you're going to have x plus 5 equals, plus or minus can be applied on any side of the equation. I'm going to put it on the right side because I want to get x isolated, and the fewer things I have on that side of the equation, the better it is. All right. So don't forget to add the plus or minus to an equation anytime you take the square root of a square. Now to finish this off, we simply subtract 5 from both sides, and that yields x equals negative 5 plus or minus root 33. Okay, so our roots are, what are our roots? Let's write them in separated form. The first one is negative 5 minus root 33. And then my second root is negative 5 plus root 33. Okay? So that is that. Okay, number 37. This is a good problem on how to use your calculator, namely the TI-83 in this case, to calculate exponential regression, okay, to generate the exponential regression equation for a data set, okay? All right, so what we're going to do here is basically enter this data into our calculators, and then we're going to use the exponential regression function to generate an exponential regression equation that basically models the data set represented by this table. All right, so let's go ahead and enter the data set into our TI-83 calculator. So the first thing we're going to do is press Stats button, and then we have Edit. Press Enter. So Stats and Enter takes you to this Edit menu right here. So we have two columns, and we're just two rows. We're going to enter them into the first two columns. All right, so L1 will be X, and L2 will be Y. So let's go ahead and enter the X first. So 1, enter 2, enter 3, enter 4, enter 5, enter. There's another way of entering values into the lists in a calculator, but that method is a little bit more complicated. This is more effective because you're less likely to make mistakes because everything is organized nicely in tables for you, okay? So we have 44.2 for the first Y entry, 33.5, 113.1, 268.1, and then the last entry is 523.6. Now, anytime you enter data into a calculator, you always want to go back and check to make sure that you entered everything perfectly, okay? So let's go over our Y entry, which is list 2. We have 4.2, 33.5, 113.1, 268.1, 523.6. Perfect. And then we just have 1, 2, 3, 4, 5 here. Okay, so now we have that done. So we can quit to go back to the home screen and then press stats again. And we're carrying out a calculation, statistical calculation. Okay, so you scroll to the right to your calc menu. Okay, now we're going to be looking for exponential regression. We're using exponential regression to model this data. So we have a lot of things here. We just keep scrolling until we find exponential regression, and there you have it, option number 0. Okay, press enter. You don't have to enter anything. It automatically takes the information you stored in those two lists and calculates exponential regression using those two, okay? Press enter, and then this is the answer you get. So you have, using the y equals a times b to the x format, a is 2.1947 and b is 3.23. Okay, so let's go ahead and write that down. We have the form that we're using is y equals a times b to the x. Okay, and from our calculator, we found out that a and b are, let's take a look at that again. So a is 2.1947, 2.1947, and then b is 3.232, 3.232. Okay, so what is our exponential regression equation? We just simply plug in a for a in this equation and b for b. And then we are also asked to write it to the nearest hundredth. So that's 2 decimal places. All right. So we're going to be using a equals 2.19 and b equals 3.23. In both cases, to the nearest hundredth, or just 2 decimal places. Okay. So our exponential regression equation equation is given by, just plug these values into that equation. Y equals A, which is 2.19, times B, which is 3.23, raised to the x power. Okay, because if you look in this function, our independent variable is x, our dependent variable is y. So we just stick with the notation that we were provided with in the question. Okay, now why is it important for us to know how to create exponential regression models? Well, exponential regression models can enable us to carry out predictions. Okay, we can solve problems using a particular data set. So with a given input or given time, we can predict an output in a future event. And with a given output, we can also predict what input will result in that output. Okay, so consider this problem that we're going to solve using that model. It says, using the equation, predict the value of x if y equals 426.21, rounding to the nearest 10th. Okay, so you see we can use our model to predict what input will result in its output. If you look at the table that we're provided with here, we don't have any output value of 426.21. But with this model, we can predict what input value will yield that output. So that is the power of exponential regression. Any kind of regression modeling, it just helps you make reasonable predictions for points that are not included in the provided data set. Okay, so what we're going to do here is rewrite our model, which is y equals 2.19 times 3.23 raised to the x. We're going to set up an algebraic equation and solve it for x. Okay, so in part B here, we have y is equal to 426.21, and x is what? That's unknown. That is what we're looking for in this problem. Okay, so all we're going to do now is substitute y into the equation and solve for x. Okay, so solve y into equation and find x. Simple and short. Okay, that's what we're going to do. So we're going to have 426.21 equals 2.19 times 3.23 raised to the x power. All right, now what we're going to do next is we want to isolate the x. Okay, so we're going to start by taking out this coefficient of this exponential term. We're going to power down x by using the appropriate inverse of the exponential function, and then we can get x isolated with no problems. All right. Okay, let's go ahead and do it. So step number 1, divide both sides by 2.19. I'm going to save the entry of my values into the calculator till the end, so that I'm not going back and forth over and over again, which can also impact accuracy negatively. So 3.23 raised to the x power is equal to 426.21 over 2.19, which just happened here. Well, when we divided this, 2 canceled out, and I just reverse my equation in this order. I need to power down x. How do I do that? Well, you can use the logarithm. Just take the logarithm of both sides, and then you can power that down. Okay, so what you want to remember is that when you take log of a to the x, this is the same thing as x of log a. All right. The base of the common log is 10, so you don't put that in there when you're working with common log. You can also use natural logarithm. You will get exactly the same answer. So the natural logarithm, namely log base e of a to the x, is x ln a. Okay, so what we're going to do in order to apply this property of logarithm here to enable us to power down x, we're going to take the logarithm of both sides of the equation. Okay, so log of 3.23 raised to the x power is equal to log of this entire argument right here, 426.21 over 2.19. Okay, and then using the property of logarithm, we can power down this x. So we're going to have x log 3.23 equals log of 426.21 divided by 2.19. Okay. All right. Now our last step is to get x isolated. So to accomplish that, we just divide both sides by what? What do we divide both sides by to get x isolated? You just divide it by log of 3.23, right? Both sides divide by log of 3.23. These two divide out, and then what we have to do next is enter this into the calculator. Now you have to be really careful about entering this correctly in the calculator. We have two logarithms here. The logarithm in the numerator has a quotient as its logarithmic argument, so you want to pay close attention to how you group your entries. Okay, so let me show you how to do it. Try that out. So we have log of 426.21 divided by 2.19, close that, okay? Divided by log of 3.23. Okay, let's make sure we entered it correctly. Log of 426.21 over 2.19 divided by log of 3.23. Where my 3 go? Enter. Your answer is 4.4956. 4.4956. Okay, so in the question we were asked to round it to the nearest tenth or just one decimal place. So since the number behind the first decimal place is 5 or greater, we're just going to round up. So our final answer will be x equals 4.5 to the nearest tenth or first decimal place. Okay, so that's basically how you can use your exponential regression models to carry out predictions. All right, let's take a look at question number 38. It says solve the equation cosine 2x equals cosine x algebraically for all values of x in the interval 0 less than or equal to x less than or equal to 360. Okay, so let's go ahead and do it. Cosine 2x equals cosine x. Now, first thing we're going to do is to try to create a quadratic equation. Okay, we're going to use our identities to create a quadratic equation that hopefully we can solve by factorization. Okay, if you look at those two functions we have here, we have cosine 2x and we have cosine x. I could use my double angle identities for cosine to express this as a square where the input of a cosine function is just x as opposed to 2x. Okay, so you want to recall your double angle identity. Cosine 2x is equal to 2 cosine square x minus 1. Remember, for your double angle identities, there are 3 of them for cosine. Okay, so if you look at your reference sheet, let me show it to you real quick. So if you go to your reference sheet, for the double angle identities, there are 3 of them for cosine. So the question is, which of them do we pick to solve the problem? Why did I select this one right here? Well, I'm trying to make the cosine functions uniform. Okay, the other ones that are present, this one has a sign that's problematic. This one has a sign that's not good. So I want to have just cosine functions. All right. So let me make this substitution here to clearly illustrate what I'm saying. So when I take this cosine 2x out, I replace it with 2 cosine square x minus 1 equals cosine x. Okay, now I'm going to subtract cosine x from both sides of the equation. Why? Well, this is a quadratic equation. You might not see it yet, but it is. I'll make that obvious in a second, okay? So this becomes 2 cosine square. Let's write it in this format so you can really understand what's going on here. So I'm going to write this as 2 cosine x squared minus cosine x minus 1 equals 0. So you see you have a cosine here being squared, and you have a cosine here, minus 1 equals 0. Okay, so how do we solve this quadratic equation? Well, this cosine makes things complicated. It's hard to see this as a quadratic equation with cosine there. It's kind of annoying. So to make it less confusing, let's carry out a substitution. Okay, so let what do we want to use? U. Okay, since x is already taken, let u be cosine x. Okay, so if use cosine x, check this out. Our equation becomes 2u squared minus u minus 1 equals 0. What do you think about this? This looks much better than this monstrosity here with the trig, components for the independent variable. So focus on this. Let's get this solved first, and then we go back to the trig portion. Okay, so converting the trig problem into an algebra problem, we'll solve this, and then we'll go back to trig and use our calculators to finish it off. Now, how do we solve a quadratic equation of this nature? Well, it's pretty easy. We can use factoring by grouping method. Hopefully that works here. AC is -2, B is -1. In this quadratic, as you can see, A is 2, B is -1, and C is -1. Okay, A, B, C. So AC goes on top, B goes on the bottom. What two numbers multiply to give you -2 and add to give you -1? We can do 2 and 1. So let's switch my colors here. I'm going to do 2 and 1. Well, in order for the sum to be negative, I have to negate the bigger of the 2. Just check it. -2 plus 1 is -1. -2 times 1 is -2. Perfect. So I'm going to replace the middle term with this 2. I have to factor by grouping here. Why do I have to factor by grouping? Is because our A is not 1, so this is longer than usual. So we have 2u squared minus 2, append the u next to it, plus 1u, just write u, that's good enough, minus 1 equals 0. Okay, now let's finish this up. We're going to factor by grouping, so I'm going to deviate down the center right here. Okay, take a look at the first two terms to the left of your partition. What is the GCF? What can I factor out? I can factor out 2u, and you're left with u minus 1. Okay, now take a look at the two terms to the right of your partition. What's the GCF? I can take out 1, and then we're left with u minus 1 equals 0. Now, whenever you factor by grouping, if you carry out your factorization process correctly, the quantities in the parentheses must be identical. Is that the case here? Yes, so you're doing good. So we factor out the identical terms. I'll just change my colors here. So you factor out this two like terms, u minus 1 and u minus 1. So you have u minus 1 times, and then what's left on the outside of the two identical quantities are combined into their own nice little parentheses here, equals 0. Okay, all right, let's keep on going. So we're now going to use the zero product property. We have u minus 1 set to 0 and 2u plus 1 set to 0. To finish this up, you just simply add 1 to both sides, and you have u equals 1. And then here we subtract 1 divided by 2. Just 1, get 2u equals -1, and then divide by 2. And then you have u equals -1/2. So the question is, are we done? Have we solved the problem? Well, let's go back to the question. What does the question ask us to do? The question asks us to solve this equation for all values of x. We have just found u, so we're not done yet. In order to finish this whole process, we have to resubstitute cosine x for u. Okay, so you sub and then resub and then you solve. Let's do it. So we're going to have, let's see. I'm just going to rewrite it here so that nobody gets confused. U equals 1, and then u equals -1/2. So when I resubstitute, I have cosine x is equal to 1 since u is cosine x, right? And then this one, I'm just going to also write cosine x is equal to -1/2 since u is equal to cosine. Okay, so now I just have to solve these trig equations. These ones are pretty straightforward to do. We're going to take advantage of our calculators here. You could use your calculator. You can use the unit circle if you have it memorized. Or you can use the trig function. I'm going to use the trig function, the graph of a cosine function, to solve this one. Okay, remember we're going from 0 to 360, so we are in the first quadrant. So for this one right here, let me graph my cosine function. Bam, bam. And you can also use your calculator to do this too. Okay, so I'm going to have cosine, that's pi over 2, that's pi, 3 pi over 2, 2 pi. It's very important to know how to solve these equations by hand, just in case you're taking higher math classes like pre-calc or calculus, when you're not allowed the luxury of using a calculator. All right, so there goes my cosine function from 0 to 360. Bam. This is 360. This is 180. Okay. All right. So for our interval, let's look at our interval. 360 is excluded because we don't have a line underneath your inequality. So our final point should be an open circle. So the question now is, where is this graph? When does it have the output of 1? It has the output of 1 on this line right here, okay, on the maximum. So what angular values gives you that output? 0. 360 would have been included had it been we had a line underneath this inequality. But 360 is excluded from the solutions, from the domain, so we may not include it in the solution. Okay, so cosine x equals 1, where? When x is equal to 0 degrees. Okay, now this is very easy to do because it's a nice point, but this one is a different story. Okay, now let me replicate my curve for you and show you why this is slightly more complicated. Okay, so I just copied this graph right here. So the maximum for your cosine function is 1, the minimum is -1. We're asking for what input values will give you an output of -1/2. Do you see where -1/2 is on this graph? -1/2 is dead in the center between 0 and -1. So we're going to draw this line right here, dead in the center. Bam. Now, what x values generate this output? That x value right there and that x value right there. So we actually have two answers for the second equation. Okay? So if you have your unit circle memorized, it's easy for you to just calculate it, to figure it out just by sketching the unit circle. But I'm going to use the calculator because not all of us have the unit circle memorized at all times. Okay? So what I'm going to do here, let me make sure my mode is in degrees because this always resets itself. I am going to graph the function, my cosine function, and I'm going to use the calculator to help me figure out my results, okay? All right, let's graph it. Okay, so that doesn't look good. I'm going to zoom trig, okay? So zoom trig, enter. So what it does now, it goes from negative 360 all the way to 360, okay? So let me show that to you. So if you trace 0, oh gosh, what just happened? So let's trace 0, that's 0, and then when you do 360, goes too far out of the domain. Well, let's do 180 halfway just to illustrate. Okay, so that's 180. It's kind of 360 somewhere here, but it doesn't include that in the window. That's a glitch in the calculator. Okay, oh, there you go. All right, so there goes 360. Okay, so this is the window that we were focusing our energy on, okay? So to help you even focus on the relevant area, I'm gonna use my zoom box feature to capture the only area that we care about in the graph of cosine. We know that its domain is from negative infinity to infinity, but we want to just zero in on the first period, excluding the right endpoint, namely 360 degrees, okay? So let's just focus in on this area so that you guys can really understand what I'm trying to do here. Enter. Okay, so we have the graph of one period of the cosine function. The question is, at what x values does it intersect with negative 1/2? So what I'm going to do is I'm going to go back to my y. I'm going to graph negative 1/2. Let's graph that. Bam. Okay, so now I'm going to use my intersect feature to figure out the x coordinates of the intersection between my cosine curve and this horizontal line at these two values here. Okay, so second function calculate, option number 5. First curve, enter, second curve, enter, guess. Just move your cursor to anywhere close to the intersection point. So there you go. Press enter. Bam. First answer is 120 degrees. So x, wrong color. X equals 120 degrees. We have another answer, right? This is another intersection right here. So let's go ahead and calculate that. Intersect 5, first curve, press enter, second curve, press enter. Guess, move your cursor to somewhere near the point of intersection. Enter. And your final answer is 240 degrees. So that's 240 degrees. So there goes our solution set. Okay, so the values of x that satisfies the original equation are 0 degrees, 120 degrees, and 240 degrees. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in getting you ready for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe for the remainder of this review series. If you have any questions on the Algebra 2 Regents exam, just ask your question in the comment section below and we'll be more than glad to support you. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.